Morning, everyone. Thanks for coming. This should be a fun one. Let the sun shine, greenhouse design and operations. My name is Nick Heiss with Denver Relief Consulting. We're a seed-to-sale consulting company here based out of Denver, Colorado, but we work across the entire country. We have some projects in Canada and Puerto Rico as well. This is a great topic for sustainability, obviously, because as cannabis cultivators, two of our main energy, consumption issues are really with our supplemental lighting and with our HVAC. And obviously, with greenhouse technology, we can significantly cut both of those consumption areas. So, great topic that we're on here today. I'll introduce, we got a great group of speakers here with a lot of knowledge and expertise, specifically in greenhouse construction, design, and engineering. First, off to my left here, we'll start with Paul Golden. He's a project engineer for Nexus Greenhouse Systems. And Nexus is really, they were one of the first larger greenhouse manufacturers that really embraced this industry and decided that they weren't afraid to work with us. And not only were they not afraid to work with us, but they were very willing to collaborate and come discuss with us what our specific needs were and what some of the differences with growing a cannabis plant are as opposed to growing, poinsettias or lettuce or some other crops. And as most of you in the room probably already know, there are some very significant differences. So the first time we started working with Nexus was probably 5 or 6 years ago even, and 5 or 6 years ago the climate and the environment around the industry was quite a bit different than it is today, and a lot of other suppliers and vendors from traditional agriculture didn't want to work with us. So again, Nexus has been really on the cutting edge of designing greenhouses specifically for the cannabis industry. And Paul has been working in greenhouses for a long time, all the way back to high school. He got his master's degree in environmental engineering from Stanford in 2009. And right now, Paul specializes in engineering and integrating environmental controls into greenhouses, a lot of which are cannabis greenhouses. Off to Paul's left, we have Nick Earls, who is a cannabis specialist at Wadsworth Control Systems. Wadsworth, like Nexus, is based out of Denver, Colorado here, and Wadsworth supplies controllers and other climate control systems such as shade curtains and blackout light deprivation curtains for greenhouse growers. Nick Earls graduated from the University of Arizona's CEAC, or Controlled Environment Agriculture Center, in 2013. And I've been down there and taken a short course down there at U of A, and I have to say it's got to be one of the best controlled environment agricultural programs in the United States today. You probably noticed his title is Cannabis Specialist, and he truly earned that title. After he graduated from University of Arizona, he managed several different cultivation facilities around Colorado. One of them happens to be my old cultivation facility at Denver Relief. So that's Nick Earls. And then off to his left, we have Mike Sacamano, and he is a sales representative from Forever Flowering Greenhouses. They're located in Grass Valley, California. And much like Nexus, Forever Flowering has really been sort of a pioneer as far as greenhouse construction for the cannabis industry. Forever Flowering has been around for 11 years now, and their very first greenhouse that they ever built as a company was for cannabis. So these guys are definitely earning the moniker of OG as far as being in this cannabis industry here. They focus on sustainability and reducing the carbon footprint for their operators and their operations. And they have really been, because they did start off building cannabis greenhouses, they've really been on the forefront of light deprivation specifically for cannabis. Light deprivation for some other crops isn't necessarily as specific or doesn't necessarily have to be quite as robust as cannabis. Cannabis is one of those plants where we really need almost 100% light deprivation, or else we have a chance for the plants to get stressed out and have hermaphroditic tendencies. All of a sudden they'll start popping off seeds. You'll get male flowers and pollen in the building. It's a really bad situation. So anyway, without further ado, I'll let Paul kick us off here.
Thank you, Nick. Oh, thank you. And thank you, everyone, for being here today in the home run stretch of the talks. My focus today is going to be kind of painting a spectrum of the differences between the two standard systems we see in place today, the warehouse culture and greenhouse culture of cannabis, and kind of discussing a little bit of what we see in practice in terms of light levels, cooling needs, humidity and dehumidification control. Okay, and the first thing I'd like to talk about is a little bit about the light differences of what we see in the field today. Most often in a greenhouse environment, we'll see one 1,000 watt HPS lamp everywhere, every spacing about 6 by 6 or 9 by 9. We've seen up to 10 by 10 in desert areas or even higher where you don't have the power to run lights. But this is pretty much a good rule of thumb, and we'll model that and figure that out for a certain DLI that we want to see in the darkest month of the year. And we'll try to stay between a target number of between 30 and 40 moles per day if you speak that language. And it's pretty easy for us to figure out that sizing. A warehouse environment that would need an equivalent amount of light, 30 to 40 moles a day, would use one lamp basically every 4 by 5 square feet, give or take. That's 1,000 watts. And it might vary a little bit if you're using LEDs, but most widely seen today is still the HPS. It's still king in the industry, it seems. Just for a reference on energy density, the power required to light a greenhouse environment on the darkest months of the year, because obviously you have light for free during the summer months, on the darkest months of the year tend to be between 18 and 30 watts per square foot. An equivalently lit warehouse environment would require about 50 to 60 watts per square foot, more specifically 52 to 66 watts per square foot. And this has implications on the cooling systems. A typical warehouse environment will typically have 1.5 to 3 times the amount of lighting, depending on the climate that you're in, that a greenhouse environment would have. And yeah, remember, you're running these lights 12, 18, maybe 24 hours a day in your veg, times 7 days a week, 365 days a year, where in a greenhouse environment, you're only running these lights during the darkest months of the year. And then sometimes you'll bookend, what we call bookend. You'll run your lights in the morning, heat up the greenhouse environment with free heat that's beneficial from the lights. And then during the middle of the day, you'll have a decent amount of light level from the sun alone, so you'll turn your lights back off. And then you might turn them back on at the end of the day to either extend photo period or just increase that overall DLI in the greenhouse environment. And I know my colleagues will talk a little bit about that too. So just as a rule of thumb, okay, yeah, I'm still on the same side. Okay, just as a rule of thumb, every 3 HPS lamps, 1,000 watt lamps, will typically take about a ton of cooling. That's a pretty high energy density on top of the already 60 watts a square foot you might have in a greenhouse environment for lighting alone. So this can range 30 to 60 on up, really, watts per square foot just for the cooling needs of the greenhouse. And that's not even getting into dehumidification and all the other aspects that go on inside there. A greenhouse environment, warehouse. In a greenhouse environment, you'll typically have about 1 to 2 watts per square foot necessary for cooling, and you're not cooling 24 hours a day, 7 days a week. You're only cooling when you have demand for it. And we would screen that environment, we would screen that incoming air. Let's see if I can find the laser pointer. We'd screen that incoming air and bring it into a staging area, kind of get it the right conditions for the greenhouse environment, and then bring it through the greenhouse environment, cool, and then exhaust hot, moist air on the opposite end. And so with that system that we have in place right now using evaporative cooling, which is highly energy efficient, it's anywhere between 1/10 and 1/20th the amount of energy needed to HVAC a similarly sized warehouse environment with similar light levels. So you can see it's a massive amount of energy savings. As a reference to the total, I think I'd like to throw some metrics out there. As a reference to a total amount of energy that a warehouse would consume, it could be anywhere from 120 to 225 kilowatt hours per square foot per year. So you can figure quite easily what your overall cost of running that for energy needs would be. And I think I'd like to throw a shout out to a couple people in the audience here. Derek and Jacob, they're doing great research to quantify this number better, and I think that it's very valid research. Basically, what we've come to find in practice is that a greenhouse would use 1/4 the amount of power that a warehouse would use to produce the same level of product. And then getting into humidity control a little bit here, I'm going to kind of first go over plant biology and how it is affected by humidity. And I'll kind of discuss a little bit of the differences between plant biology in a warehouse environment versus a greenhouse environment. Similar plant, but we have a different overall system that runs that climate control. So you're able to do a little bit more with it. And then I'm going to discuss when and where supplemental dehumidification is necessary. when is humidity control most important in the greenhouse environment, and the types of supplemental dehumidification there is out there right now that we can apply to greenhouse environments and have. So the first thing I want to get into, and I don't want anyone shooting arrows at me if they're cultivators, is a little bit about the level of humidity inside a grow environment that's appropriate for this crop. And one of the big commonly used phrases in a warehouse environment is 50, 70, or 50, 75. 50% relative humidity at 75 degrees. And that's based off of practice. Obviously, they know what's going on. They've been doing it for years. But it's based off a system of climate control that's not really applied in a greenhouse environment. That's based off an HVAC system where you might have a 50-degree air temperature coming out of that ductwork. And if you have 50% relative humidity in a warehouse environment and it's 70 degrees there, where it's being blown on the crop from the duct, it can be much higher relative humidity and possibly causing condensation, which is the overall root cause of any kind of disease that we're going to have caused by mold or anything like that. So condensation is one of the big keys to focus on in a greenhouse environment. And one of the ways that we've traditionally measured the potential for condensation to happen on the plant is using vapor pressure deficit. And imagine, show of hands, how many people have heard vapor pressure deficit? Okay, well, that's good. So if you know what vapor pressure deficit is, it's basically saying the ability for the air in the environment to take on moisture and the likelihood that condensation will occur when there's no more ability for the air to take on moisture. Kind of depicted by this diagram below. It sounds like most people know what's going on. And so the more moisture in the air, the harder it is for the plant to transpire, the easier it is for condensation to occur on that binary layer right there on the plant leaf. And that's the cause of most disease that you see. So what we've come to find is that 50% relative humidity, if you're below 60-something degrees, your vapor pressure deficit is very close to the point where you can have condensation occur. And so if you're using a warehouse style of cultivation and you have ductwork blowing on that crop right below, right where next to it it's 50% relative humidity, but locally in this zone it's much higher, you're creating an environment where outbreak can occur and then spread. And so in a greenhouse environment, if we can create proper mixing, you can bring the relative humidities quite a bit higher and still be safe from disease, as long as you have adequate mixing and an adequately engineered system. And so a little representation of what this means here. Likelihood for condensation to occur is at VPDs of 0.2 kilopascals. Most often, what you'll see with that 75, 50% relative humidity, that means the VPD of basically 1 kPa, 1 kilopascal. And if you can keep that VPD constant throughout the greenhouse, you're going to end up having a better environment for that crop overall, as opposed to swings in humidity. Swings in humidity cause a lot of outbreak by causing spores to occur and then set in on the crop. And so if we can keep the VPD in a greenhouse environment between 1 and 0.85 kPa, we can graft a zone that's the ideal temperatures for that environment, ideal temperatures and relative humidity. And you can see at 70 degrees, it's somewhere right around 50, 55% relative humidity. And that's going to vary depending on the crop stage, right? But if you're in a greenhouse environment, most often you're operating higher temperatures. It's better for the crop. It's more productive for the crop. So you're usually more around 80 degrees, especially during the summer months. And so that allows your relative humidity to go up quite a bit in a greenhouse environment. If you get away from the traditional spec that you thought you need to keep and you move into more of a VPD-based control system, you're going to ultimately save a lot of energy in your operation over time. And then, okay, when is humidity control most important? I always tell people humidity control is most important when you close the blackout curtains in the greenhouse. What happens when you close the blackout curtains in the greenhouse is the crop's heavily transpiring. You might be 7 o'clock at night in a summer day in July here. In your greenhouse environment, it's 80 degrees, and you're just pumping away. Those plants are pumping away, they're growing. And you close that curtain, instantaneously you shrunk the shell of the building, because that's an impermeable curtain for the most part. You shrunk the shell of that building, so you shrunk the overall volume of the air, which allows the humidity to rise pretty quickly. So what I would recommend is purging that air out of there with just a timer, or just slowly putting the plants to bed too. That's another big thing. So you can close that curtain slowly, slow down the transpiration, slow down the light levels inside the greenhouse environment, purge, and mix outdoor air. If the outdoor air is anywhere between, if it's 60 degrees and it's raining outside, if you bring it up into the 80-degree range inside the greenhouse environment, you're already at below 50% relative humidity. So you're in spec for what you for your traditional metric for spec, right? So that's one of the first things you could do. And if the environment that you place the greenhouse in is not capable of doing that because it's so hot and so humid outside, that's when we would say start to apply supplemental dehumidification. Seal up that greenhouse, cool it down, and I'm sorry, not cool down, maintain temperature, preventing it from cooling down too quickly and causing condensation in the plant, and then apply your supplemental dehumidification equipment. And so in terms of supplemental dehumidification equipment, there's two basic systems out there in the market that are kind of plug and play today. They're based off two different types of technology. One is a compressor-based system where you have cooling coils that condense water onto these cooling coils, and then you pull that water off that system and drain it, and that's coming out of the air. It's recirculating air constantly, and it's typically seen in the dry air systems and the Quest systems, a handful of other HVAC systems that are compressor-based will operate this way. These systems will reject heat into the environment. So that's something you will have to keep in mind. If you're in a hot climate and you're closing it up and trying to dehumidify, let's say you're, I don't know, southern Florida, and you're trying to close it up. Well, you have the heat from the envelope, from the envelope, if it's not too well insulated, increasing the temperature inside the greenhouse environment. Plus, you have the heat off these compressor-based systems. The other system out there is a desiccant-based system. It basically uses a salt brine to absorb moisture out of the air. There's claims that helps with purifying the air too. I haven't seen any substantial evidence, but it seems to make sense. And this system typically would reject that hot, moist air out into another environment and recharge that desiccant. And then now the desiccant's able to absorb more moisture out of that greenhouse environment. These systems tend to reject heat as well inside the environment, but they can be refrigerated. So in certain cases, you'll see refrigeration applied to both actually compressor-based systems and desiccant-based systems to maintain a homeostasis inside the greenhouse when you go into blackout. So your temperature doesn't swing up and down too much, and all that happens is your relative humidity gets pulled down. Most importantly, though, is mixing. I mean, it doesn't matter whether you have the best system in place for dehumidification. If you can't mix that air properly and keep condensation from occurring on a microscopic level near the crop, then you're going to have problems. You'll have dead zones and issues like that. And there's two basic styles of operating a dehumidification system. Basic style is just doing it during the nighttime conditions and letting your greenhouse operate as normal during the daytime conditions because we can allow that temperature to come up, and that means there's more capacity in the air for holding moisture and less risk of disease occurring on the crop. Or you can completely seal up that greenhouse. And now what you've basically done is you've lost a lot of your efficiency gains. So by sealing up the greenhouse, that means you have massive amounts of HVAC in order to cool that environment because you have more light in the greenhouse than you would in a warehouse environment, and that light's directly related to how much energy there is in there to cool it. And then, you're by circulating air through a greenhouse environment, that's how you naturally dehumidify. And so now you have to apply additional equipment to handle the latent load, which is the moisture transpired from the plant, and that takes a lot of energy as well. So what we would typically recommend is to do a semi-closed greenhouse design where you close the greenhouse during the nighttime environment and then you dehumidify. And that's only in the cases where you need to. Very rarely here in Colorado. Very rarely in any place where you have a regular dew point temperature that's below about 55 degrees. So if your regular dew point temperature is below 55 degrees, you're pretty much able to just heat that air up inside the greenhouse and stay with relatively low relative humidities or high VPDs, unless of course, it's very hot and humid and above 55 degrees dew point temperature, and that's like places like Florida where you might have to look into supplemental dehumidification. With that said, I'm going to pass it on to Nick. And I lost the slides there. There you go, buddy.
Thanks. Thanks, Paul and Nick. All right, so I'm going to mainly talk about using total environmental commercial controls versus using some of the hobbyist approaches or using multiple controls to get, the ideal climate, and all the benefits that go along with that, and how to use your environmental control to its full potential. I'll also be talking about variable speed and multiple output equipment which a lot of people I feel like don't know about. And when you're designing a greenhouse, it's going to have a huge benefit on your energy cost and optimizing your climate. So first I'm going to talk about, branching out, getting out there. Sometimes you're used to something, using a rainbird irrigation timer, or using multiple thermostats, or using all these different things where in the end, if you're using a total environmental commercial control, you're really going to get the whole picture. You're going to have things that work together. So if you're trying to dehumidify like Paul was talking about, and you're in an area that might not need a giant, dry G air unit, and you want to just vent and heat to dehumidify in your greenhouse, you can't do that with two different thermostats. You can't, you need to have some type of full environmental control system. So that's kind of getting from using the hobbyist approach to going into a commercial grade system. So that kind of talks about multiple controls versus using a single control. And also using a single control that can run all your zones. So if you have a bunch of controls, each for each single zone, it can be a little tedious going, if you have a computer system that's working each one of those, you're going to have to go to each zone or walk into each greenhouse to change any set points, look at any data, or anything like that. But with a commercial grade system, you can. Embrace the new technology. A lot of times people are getting a little scared about having a total environmental control system because, again, you stick with what you're used to. And so embracing this new technology, a lot of these great commercial grade control systems out there, Wadsworth, Argus, Priva, a lot of these well-known brands, they did everything they could to make it very intuitive, very easy to use. So don't be scared. A lot of times you see old farmers that have old school styles, and embrace the new technology. Flow and facility design. Paul touched on this a little bit, talking about when you're designing your facility, think about, I'm not going to go into it too much, but think about where you're putting these controls. Sometimes I'll see facilities where they put a multi-zone system in one zone, and so every time you need to go and change something, you need to go into that zone. And that's just cross-contamination. If you have an issue in another zone, you have to run in to change something. Just kind of, it sounds basic, but I've seen it many times. Security and passwords, definitely have some type of security or password on your commercial control system. I don't know if I know any that don't have it, but utilize that, because I've seen that many times, like, oh, well, we know we have the password option, we just really haven't set it up. Well, it has a benefit to it. A lot of the systems out there also have options of having different users, or also having where you can only change things with a password. And I like that because I've had employees before that want to learn. They want to learn more. They want to be part of how the control system works. They want to look at things. What are the set points? Look at graphing. But if they can't do that without having a password, there's an issue, and they could change things. They could, screw up some of your system, jeopardize your crop. And, a lot of these commercial control systems have the option of letting your employees go through without making any changes. And I think that's huge. If your employees want to learn, let them learn. Give them that option. Backup generator. Something I see a lot is not having a backup generator, or a lot of these commercial systems, you can set up what you want on your backup generator or change things, and you might not want everything all at once. You might have a generator that's only sized for a certain amount of power, and that's huge. Benefits to a total control system. And this kind of comes together where everything works together. You kind of see on that chart over there, temp, humidity, CO2, all these things can work together. If you're calling for heat and you also need CO2, you would, if your system could go ahead and turn on a CO2 burner inside your greenhouse to start supplementing with heat and adding CO2, and then maybe kick on your heater if you still need more heat after that. But that's a benefit right there with a total control system. Same when it comes to temp and humidity. Paul did a great job talking about air circulation and airflow. And one of the things is, a lot of times I'll go into a facility and there's tons and tons of fans in there, and you'll start to see wind burn on certain plants and some not on others, and that can be a big issue because now you don't have an even climate, you don't have even airflow, and you're jeopardizing your crop by pushing all this air on that isn't necessary. What if your greenhouse is within set point at that time? So with a total control system, you could set things so you can ramp them up. You definitely need air circulation. But if it's at the right temp and it's at the right humidity or the right VPD, why would you have that much airflow at that time? One, you're using power. but you're jeopardizing your crop. So if you had something like a total control system, you can ramp up those fans if you need it to. If it's out of set point range, let's ramp it up. Let's get some airflow going. So that has a huge impact. All these little benefits to using the system. With this, you can also compare sensors and equipment readings. So you can see if your equipment's turning on and off all the time. Maybe you need to adjust your set point. Now you're using too much power. You can still optimize your climate by adjusting your set points and using the graphing and analyzing the data. And we'll go into that in a second. I'll show you a nice graph with some data and how to use that to your benefit. Alarm systems, if you have tons of different systems, a lot of times you'll have different alarms come from different places. Everyone wants to have some type of alarm for everything. Have backup options. If you're basing your irrigation off time, put a moisture sensor in that zone too. So maybe you didn't up the time and your crop's growing right now. You might want to have a backup option of maybe it waters on BPD as well. Maybe it waters on moisture content. So if your moisture content isn't at where you set it at, and it hasn't watered yet, it will go and water automatically. And these are benefits from using that total environmental control. You want to be able to remote in. I had a facility I was running, it was a 2-hour drive away from where I lived. And if I had an alarm go off, the first thing I wanted to do was be able to have access to that controller. So that's a big one. Multiple set points, and that's what I just kind of get into. Irrigation, you could do VPD, you could do time, you could do moisture content, you could do DLI, you can water and control a lot of things based on a lot of different options. Hybrid, we see a lot of indoor, veg, indoor mom areas, maybe even genetics inside, and then they're doing flowering outside. If you have a total environmental control, you can control all that from one system. I have a lot of clients that are controlling their drying rooms as well, because why wouldn't you want to have everything on one system? Drying room might have, mini split systems with humidifiers and dehumidifiers to kind of keep that set point where you need. And you'd want to be able to walk up to a system and look at everything and control everything from one system. So this is kind of getting into the data analysis, and this is where a lot of the savings come into play when it comes to sustainability. So looking at this graph here, you can kind of see it's a little shaded there, but on unit heater, you can kind of see that there's a gray spot showing that unit heater turned on. And I know there's a lot going on this graph right now, just to kind of show you there's a million things that you can graph. But you can go ahead and set up, temp, humidity, VPD, look at your heaters, look at your venting. Wow, why is my heater going on and off? Why does it keep going on and off constantly? Well, let's adjust the set points so that we're saving on utility cost. And, again, still optimizing our climate. Past versus future data. If you, last year at the same time, you had a fantastic crop, and, right now it's not going as well. You might want to look at, what were your set points, graph your set points, graph your sensors, and graph your equipment, and see what's going on so you can kind of adjust things back. Sometimes you start adjusting one thing, you adjust another thing, then you adjust another thing, and you want to know where you originally started, because maybe you need to go back and start fresh where you originally were. And so you can use that all from using this data. Overrides are big. So talking about, if you're dehumidifying by using venting and heating, you'd want to know when that override's coming on. So you'd want to graph your set points for the override and graph all your sensors. Again, helping with saving on your utility costs, but again, optimizing climate. I talked a little bit about irrigation duration versus moisture content. If you want to figure out how much water you're using, maybe you go from an indoor grow and now you're growing in a greenhouse, there's going to be a lot of different changes. And so looking at this will help you determine your irrigation schedule, will help you to determine what you need to adjust to get the optimal climate. Full potential of your control system, keep pushing it, but obviously it sounds basic, but read your manual, and I highly recommend getting some training. There might be features on there that you didn't know about that now that someone explained it to you, you understand. I'm one of those people that when I read something, it turns out okay, but if someone shows me and I make a memory of it and I'm there, I tend to learn it a little bit better. So keep that in mind. Have a climate plan. Put together what stages you want for your cooling. And I'll kind of go into multiple outputs. If you have 4 exhaust fans, you could have 4 outputs, so meaning 1 set point per exhaust fan. This will save on your utility costs of 4 fans turning on at once or 2 and 2, but also, again, letting the staging come on so that you can still bring down that temperature without using too much of your electricity. Advantages of more sensors, you can kind of see in this picture right here, it's a smaller zone. We have one temp and humidity sensor in there, but we could add more. For the research facility, we could take an average. But we typically put something like this in a smaller house right in the center, so it's right, same distance from the exhaust fans from the pad wall, because pad wall obviously is going to have a higher humidity than when you get over towards the exhaust fans. So you can add more sensors when it comes to irrigation too. I recommend basing your irrigation layout plans based on if you have, one strain over here. If you have Blue Dream versus some other strain that might grow a lot shorter and use less water, you're going to want to put those on different irrigation zones and have different moisture sensors in there to be able to water properly and not overwater, so that can cause botrytis or bud rot within the plant. Shade and light depth curtains, depending on what area you're in, I recommend sometimes having both. And when you have a shade and blackout system, make sure it's on 2 outputs, meaning that you can modulate that, you can slow it down. Paul talked a little bit about slowly opening that blackout curtain, so then you can kind of mix that air. And also if you're in certain areas and certain times of the year, you're going to get condensation up there. If you fully open your blackout curtain, one, you don't have that slow mixing of air, but all that condensation is going to be raining down on your plants. So use your environmental control. I know Paul does a great job. They put a lot of times shutters, and they put gable exhaust right up above your curtain system, so that we can, and put a sensor up there, so we can go ahead and dehumidify that zone before we open up your curtain, so we don't have water raining down on your plants. Set your overrides, dehumidification, CO2 I talked about, using as supplemental heat, moisture sensors, PAR. If you could base your light levels on PAR, but also base them on DLI. And Paul mentioned that. Be able to, keep a consistent level throughout the day, but if you didn't get the amount of DLI or accumulated light by the end of the day, make sure those lights come on and finish up to hit that number you're looking for, which, 30 to 40. Roof vents and weather stations. If you don't have a weather station, you have roof vents. I've seen a lot of disasters before, and mainly wind. So high winds coming in, and those roof vents aren't overriding and shutting. You can have panels lost, you can have roofs fly off. Making sure, a lot of times it can be a little bit more of an upfront cost, but it's worth it in the end. Lights and heat. There's a lot of systems out there using, if you put your lights on a checkerboard pattern, which I know Shelley the other day in the lighting discussion talked about, using a hybrid system with LEDs and double-endeds. Even if it was just the same type of light, having those on 2 different outputs or 2 different set points, so you're not using tons of utilities right up front, basing them on different PAR levels, and maybe turning on one bank of lights, so one of the checkerboards. If you're not still at that level or it gets cloudier, then kicking on the second bank of lights. You can also use your lights as heat. Use them as supplemental heat. Or if you're indoors and it gets too warm, have it kick off one of those banks of light and also send you an alarm. Say, hey, something's wrong. Maybe a condenser went out on an HVAC system. Something's going on in there, but now you're alerted and your crop is safe. When it comes to variable speed and multiple output equipment, I feel a lot of people don't know much about this, and it has huge benefits. And I talked a little bit about the half fans, like air circulation fans, ramping them up and down or keep them at a lower level if it's within set point. That's huge. You can do the same thing with your exhaust fans on your greenhouse. You can set them to a variable speed, or you can set them up, you can get 2-speed exhaust fans. Maybe your first stage of cooling is going to be one exhaust fan on low, or 2 exhaust fans on low. Maybe you have 4 fans. And then if it's still not within set point, it's still going up in temperature, we'll go ahead and kick those fans on high, saving on utility cost and still, again, optimizing climate. Multiple output equipment. That I just kind of talked about. Exhaust fans, if you had 4 of them, put them each on their own output. Then you have your own set point for humidity and temperature, or VPD, based on each fan. So now you're not using, if each fan's drawing 10 amps, you're not using 40 amps right off the bat. You're maybe using 10 amps, or if you have a 2-speed fan, you're starting with 5 amps and then going up to 10 amps. It's going to save you a lot in the end on your overall cost. Same with lighting, multiple outputs, just kind of talked about that. I know Neil Yorio over here, BIOS LEDs. all their fixtures, they have a 0 to 10 volt connection, meaning that you can ramp up or ramp down your lights. So if you have a total commercial control system that can do it, you can basically ramp up or ramp down your lights based on a parlay. Heating, no one wants to turn all their heating on at once. Sometimes we see unit heaters, sometimes we see unit heaters with floor radiant heat or fin tube. Have your own set points for all those so that you can benefit from using too much upfront utility cost. But again, you can look at your data and your graphing to be able to adjust this. Curtains and shade systems, I already talked about that. Multiple outputs is a better way to go, so you can slowly open those curtains. I'm going to turn it over here to Mike.
Thank you, everyone. Thanks, Nick. I don't have a bunch of fancy slides or anything to show you here today. I was just going to kind of tell you a little bit about myself, a little bit about FFG, and some of the things that we've seen over the past 11 years, and some of the things that I've seen specifically over the past 7 years. Right now, one of the things that's pretty hot in the cannabis market is retrofitting existing facilities. Not a lot of people touched on that today, and that's pretty important too. To start, Forever Flowering's been around for 11 years now. 2017 marks our 11th year in business. The first greenhouse that Forever Flowering ever designed, ever built, ever was cultivated in was designed to produce cannabis. I think that statement goes a pretty long way. We haven't been in business for 40 years, 50 years, as long as some of these other guys, but we haven't been growing tomatoes, we haven't been growing peppers, we haven't been growing lettuce. We've been cannabis guys from the beginning, and it's something that we're extremely passionate about. And because we've taken that approach, we've kind of seen a lot of things done different ways than a lot of things we see in traditional agriculture. A traditional agriculture greenhouse, in many cases, is set up to lose money every harvest. I've been on greenhouse tours for retrofits where they're currently doing cut flower. Every dumpster is full to the brim of plants that they're throwing out because they didn't make the grade. How many producers are here in a plant count market? Okay, you raised your hand. So if the plants that are in front of the evaporative cooling pad and maybe have a little bit of mold on them, can you just throw those out? No. If we were growing roses and one tray of roses had some mold, this, that, whatever, throw it out. You got 10,000 more. The bay's full of them. Huge difference, when we're working with cannabis. So I just took a little some quick notes here on some of the stuff that I heard put out, and one thing I want to stress is I didn't really hear any bad information. Okay, we're dealing with some pretty smart guys here, been doing it for a really long time, so I definitely have nothing negative to say in that regard, just how I feel it's relevant to cannabis production. Again, that's all I know. I've been cultivating for 15 years. I've been with Forever Flowering for 7 years. As of late, we've been doing a lot more consulting versus new structures. Like I said, a lot of people in California are rushing to retrofit existing facilities to be grandfathered in before the first. Evaporative cooling, I think that's something that's totally climate specific. I would never put an evaporative cooling system in a greenhouse in Salinas, California, somewhere near the coast that's got a ton of moisture in the air. I would never put an evaporative pad cooler in Portland or in Seattle. On the other hand, for our clients in Desert Hot Springs, the first thing they need is a giant evaporative cooler. So, again, knowing how all this information specifically relates to cannabis is a big deal. A quarter of the energy for the same level of product is something that I hear a lot. In my opinion, again, being biased as a cannabis producer, I think greenhouse product, when done properly, is superior. Why do I think that? Well, ask any lighting manufacturer what they're trying to replicate. The sun, right? So, with the proper light shades and filters and things like that, I think you can achieve a higher level of quality and a full spectrum product out of a greenhouse versus artificially controlled indoor. It's kind of ironic to hear, excuse me, all these producers with, natural in their name. right? Well, how is the plant grown naturally? Inside under a light, outside blowing in the breeze in the sun, right? What's more natural? So, again, for me, it's more specifically about the plant. There's a lot of talk about temperature and humidity, a lot of good information there as far as VPD goes. In my opinion, root temp and leaf surface temp, far superior, okay, than what's going on in the air. To me, if you're growing inside in a warehouse, sure, air temperature is key, but we can set up a greenhouse in Desert Hot Springs that is bringing in outside air that's 110 degrees and, have it perform the same as, a greenhouse that's in the winter in Michigan. Just by using different techniques and having different types of equipment. So, again, how can you do that? Well, you can keep the root temperature the same, you can keep the plant surface temp the same. In that scenario in the desert where you have 100-degree ambient temps, not many indoor growers in a warehouse would advocate to run their room at 100 degrees, okay? But if you could filter out that light, using your PVCs, move the air around enough, the actual temperature on the plant leaf surface isn't going to be 100 degrees. That's what's going to matter. Cooling or heating a greenhouse in the winter, I see a lot of forced air systems as opposed to radiant floor systems. Why is a radiant floor system better? Well, it heats the roots, keeps that root ball nice and warm. The way the plant works, it's going to pull the temperature or pull that heat right from that root mass and distribute it evenly through itself. So canopy temp, plant surface temp, root temp, to me, far more important, far more easier to control in a greenhouse than your ambient air. A greenhouse is designed to have a ridge vents, roll up sidewalls, move air through. That's how a greenhouse works. Greenhouses aren't necessarily designed to be sealed other than in winter type environments. So in my perspective, you have to look at your climate zone as if is this a summer mode greenhouse? Is this a winter mode greenhouse? And those both look like two different greenhouses. Okay, there's not necessarily a one size fits all for your greenhouse. So when you guys are deciding, where you're going to source your greenhouse, you got to look at where these structures have been built, what types of structures have gone where, what's effective. Some commentary about blackout at night, that's something we hear all the time, and a lot of people nailed it on the head. People will pull their tarps at night, it starts raining, everybody freaks out. Well, one of the things that I always will preach to somebody is, once the sun goes down, open up your blackout curtains, okay? You can stand outside with a light meter, and as soon as it reads 0, you can open up your curtains. I wouldn't ever leave my plants covered all night in my blackout if I was in the proper environment. So little things like that operationally, you should not have to pull your tarps, more than one time a day. Pull them, when the sun starts going down, and you open them back up when it's nighttime. So again, not a huge fan of a closed up greenhouse. As far as controls, I think Nick had some really great information as far as hobby controls versus commercial controls. That is going to make a huge difference, and that's something that we see all the time. People are in commercial structures with hobby grade equipment, and that is setting yourself up for failure. Overall, this topic is greenhouse design and operation, and I can't stress enough how important the design and the way that you guys as operators are running these facilities is going to affect your day-to-day business. Yesterday I got to listen into Jacob's renewable on-site energy thing, and they were talking about the different footprint of, the different types of systems on your site. How you design your greenhouse might determine what type of energy system you're able to put in. How you design your greenhouse, how big are your plants going to be? If your shade system is, at a 12-foot ceiling height versus 14 foot, that's going to limit how tall your plants are going to be. How tall your plants are going to be is going to determine, how much yield you can produce. You might want to grow big plants if you're in a plant count state. If you're in a non-plant count state, you might not never, get to 10 feet plants. So again, all that stuff matters. And if you don't work with the firm that gets that and understands that, sure, you can end up with a really nice greenhouse, but is it going to meet your specific need for your specific market? I don't know. Flow and design, again, super critical. A lot of people aren't planning workflows, like how you're going to get the plant from the tray to the cure to the process to the this to the that. I've been in greenhouses where the doorway is not wide enough to get a tractor through, things like that. And I've seen guys that are growing plants that are bringing them in on a forklift and setting them down on a pallet. So workflow matters. Knowing how it goes from flower to the jar is a huge deal. And you can have acres and acres and acres of production in a brand new greenhouse. If you can't get it to the shelf, what good is it? No, it's no good. Training, I wish I could have broke into applause when I heard that, because that's something that needs to be emphasized more across the board. We work with a lot of producers, and when somebody first wants to buy a greenhouse, one of the first things they'll say is, we want to build the spaceship. We want the most high-tech greenhouse. It's going to be a race car. It's going to be this. Never one time have I ever heard anybody say, we're going to build the spaceship and we're going to train the Space Corps. No one says that. Okay? And if you guys wanted to get out and go start IndyCar racing, you'd buy your race car, you'd hire a race car driver, or you'd learn to race. Right? So training is super important. If you don't understand how your controller works, your controller is going to be the bane of your existence. If you don't understand how your greenhouse functions, that it has a ridge vent, why it has a ridge vent, you're screwed. I don't know how else to put it, to you. You have to understand what you're getting into. Anybody here interested in a greenhouse? You guys are leaning that way. Has anybody here taken similar courses in greenhouse production like any of these experts on this panel? Okay, one or two. So, for everybody else that's out there considering that, where are you going to get trained? Who are you going to work with? How are you going to get this kind of experience that you're going to need? Because that's huge. Like I said, I'm not going to try to stand up here and tell you that, FFG's greenhouse is better because of XYZ, because the reality is whether it's a Forever Flowering greenhouse or a Nexus greenhouse or any of the other greenhouse companies that are out there, the operator is going to determine what's successful or not. Okay, and the only way that you're going to be successful is if you're willing to either get good on-site training, work with a good master grower, which that could be its own topic in and of itself. But you have to be willing to accept that things that you know and things that you know that you don't know. So overall, greenhouse design and operation is a major choke point. Okay, and if these facilities aren't designed right from the start, you're going to have problems with it the entire time. And we see a lot of projects that, will start out one way and end up very differently. A lot of people will, want to do, hey, look, we just got our funding. We want to put up 5 acres and, we want to do it this way. Well, generally, the first structure ends up looking a little bit different than the last structure. Things usually change. Your market might change. Your funding might change. The laws might change. You guys have a lot of these different variables, and we're talking about structures that are designed to last for 30 years. Okay, how many of your cannabis business plans are 30 years long? Not many. Okay, a Nexus structure is going to stand for 30 years. An FFG structure is going to stand for 30 years. Okay, I imagine Wadsworth products will stand the test of time. I've been in greenhouses that were built in the 80s for the cut flower industry in Salinas, California, and seen Wadsworth controls still doing the same thing. Okay, so again, you're talking about major capital investment here. A lot of commercial sized greenhouses can easily approach 6 and some cases 7 figures depending on what you're doing. So my best advice to you and what I would tell you from an design and operational standpoint is everything in cannabis is always pump the gas, pump the gas, pump the gas, go, 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 go. You were late. If you're starting today, you're late because you should have started yesterday. Well, with your greenhouse, pump your brakes, slow down, okay? Make sure, every T is crossed, every I is dotted, because that is not something to rush, okay? The greenhouse will probably be around a lot longer than you are owning your business, okay? The greenhouses that you might be considering buying or moving into might already have existed longer than your business has, or even regulation in some states. So, if you're not starting from the ground up and you're doing some type of retrofit, whatever the case is, you have to look at the framework that you have available to you. So, you can control that to a degree in the way that you're designing it. You can control that to a degree in the way that you operate it. Like I said, opening blackout curtains at night versus leaving them pulled all night, things like that. Those are little subtle differences that, might work for you in Santa Rosa, might not work for you in Detroit. Again, it's just going to come down to, when you make that call to your master grower or to your greenhouse company or to whoever, who's answering the phone? What kind of service are you going to get? What kind of knowledge are you going to get behind that? Because these aren't tomatoes, okay? These structures aren't designed to lose 20 to 30%. That is simply unacceptable in cannabis. So, in my opinion, as far as sustainability goes, I think that greenhouse is the obvious solution compared to an indoor facility. I think eventually, and this is just my personal view, I think eventually indoor facilities will be regulated out of existence, and I think that we're going to see more and more things go to greenhouse. Right now, there's hundreds of acres of existing structures that are empty in places like Southern California and other major agricultural hotbeds. Okay, these facilities are getting picked up by these new cannabis guys that are coming in, and they're finding a lot of different challenges because they're working in a facility that was designed to lose money, that wasn't designed to be 100% effective. So, again, just understanding how all this information relates to you as a producer, and translating how that actually works in your specific scenario is going to do you guys a lot of good. So again, I do apologize that my slides didn't make it here, but that's just kind of our opinion on how we look at it. And again, not that there's anything wrong with growing tomatoes for 40 years or anything like that. It's just, cannabis is all we know. Cannabis is what we know best, and cannabis is all that we've ever done. We've never turned anybody away because they were growing cannabis. We've never put statements on our website that our products weren't intended to be used for cannabis or anything like that. So we've always welcomed your business. We've always wanted to be part of the community. FFG has gone a long way to bring this community forward. So I appreciate everybody's great knowledge up here. I appreciate you guys taking the time out of your day to listen to me, and I appreciate Nick for inviting me to this panel. Thank you.
Okay, so we still have a few minutes left here for Q&A. Anybody that's interested in asking a question, please step up to one of the microphones here, as we are recording, and it would be nice to be able to capture the audio. And I guess I can kick it off a little bit here. A lot of what we've talked about today is sort of the special needs of cannabis and how, like Mike mentioned, it's not just building the facility, it's understanding how to operate that facility. Could any of you guys give recommendations or examples of current operators as far as closing that blackout curtain? I know Paul mentioned closing that curtain more slowly so there's not as big of a spike in temperature and humidity, and we're trying to avoid that condensation on the plant. So are a lot of operators you guys working with taking 10 or 15 minutes to close those curtains at night, or is it 60 minutes or more? What are you guys seeing?
Well, I'll start that off since I just got finished talking. I see most people taking the 10 to 15 minutes because that's simply how long their motors take to shut the curtains. Again, we're big fans of opening that curtain back up once the sun's gone down. You can't go outside. There's outdoor grows all over the world that have been growing outdoors for 6 to 9 or however long you believe the earth has been in existence, right? So none of those plants are herming off the moonlight. So to think that you would have to have your curtain closed all night, which creates all these other environmental problems that needs all these other controls and all these other complications, to me is crazy. I'm in the fan of, okay, look, it's coming up on my 12, I'm going to start my thing, I'm going to go have my dinner, I'm going to come out, it's dark, and I'm going to open my curtain, and I'm only pulling tarps once a day. I don't necessarily like to see these guys that are getting up at 4 a.m. to beat the sunrise to cover up or uncover, and they're out there twice a day. I mean, you can't, everybody is doing this for a better quality of life, so you don't necessarily want to be a slave to your greenhouse. Like back in the day, the Hills of Mendo, where, oh, it's 3 o'clock, got to get back to the farm. There's good technology like controls and this, that, whatever that exists. So, You know, I think that it's pretty much limited to what the equipment will allow you to do.
I'll touch on that a little bit. And it also kind of goes down to what Michael was saying about, you know, different areas are going to have different concerns too. So if you're in California, it's really nice out. You know, maybe your style is you like to open it when it's, you know, dark at night so you don't have your curtain covered. But if you're over somewhere where it's really, really cold, you're probably going to be using your blackout system as a heat retention. So just save on your utility costs, keeping all that heat down and in there. So again, it's going to depend on what area you're in. And when it comes to opening that curtain, like Nick said, if you have a good control system, you can set your parameters of how much you want it to open and how much you want it to pause before it starts opening again. And you know, I've seen a lot of designs that are doing, like I mentioned before, like a upper peak gable shutter and an upper peak gable exhaust, so that we can go ahead and put a sensor up there for temp and humidity and go ahead and get a lot of that condensation out before we even open up that blackout curtain. Or if it's already open, you're taking care of it throughout the night by having that option available.
Yeah, I would go ahead and add to that. I agree with both these guys. I think we have facilities, cannabis facilities in 15 states now, so there's a wide variety of the ways of operating the blackout curtain. Certainly putting the bed slow every time is the case, regardless of where you're at. But whether you're opening it or not during the blackout hours, some growers like to, some growers don't. Some growers are in climates where they need to keep that closed for different reasons, for condensation control, for heat blanket. You know, it doubles your R value, your roof. So I think it's all climate dependent. But I will, however, mention that there's two other aspects of kind of going into blackout that are pretty important for overall climate control in the greenhouse environment. First would be to turn off your lights or phase your lights down prior to going into blackout. Obviously, you don't want to close your blackout curtain at some rate. It doesn't make much difference if you're running your lights all the way up to the point of blackout, right? So that's kind of important. And then most growers will also, depending on the climate they're in, if they're really in a humid climate, they'll turn their pad wall system off and continue to move air through that pad wall system for about a half an hour prior to going to the blackout. You'll still get some functional cooling until the pad wall dries up, but basically that removes a source of moisture in the greenhouse environment. And the first thing I mentioned when you go into blackout is you kind of want to ventilate pretty heavily. Maintain temperature and ventilate. So you want to keep temperature high, because obviously you just close that blackout curtain, your temperature should drop because you just lost your primary source of heat, which is sunlight. But maintain temperature and evacuate the moisture out of the greenhouse environment. And by turning the pad wall off a little sooner, you have a little more advantage.
Actually, Paul kind of spiked something up in my head that, you know, kind of it happens in certain areas. Pueblo is one of the ones I'm thinking of, Pueblo, Colorado, is, you know, sometimes depending on what county you're in, if you have a good control system, I know one special feature we had to add, and it was for Pueblo, Colorado, is because they have to have their blackout curtain shut to turn on their lights because of light pollution. Mm-hmm. So that's another thing that, you know, the blackout curtains have been used for. And just something to keep in mind if you're going into an area that could, you know, that has something like that, make sure whatever control you're going with has that option available, because that's going to be a huge concern.
Hey guys, thanks for the great information. I think I heard we all know that the cannabis plant is very special. I think I heard one mention of how cannabis is different to grow than other crops in greenhouses, contamination risk, I think I heard, but would you guys mind summarizing that? Appreciate it.
We could start and move down if you like that way.
Yeah.
Well, the one primary difference between the cannabis plant, there's two primary differences I could think of between the cannabis plant and most other plants. It's a soft plant. Its leaf surface doesn't have much of a cuticle, doesn't have much protection against disease, so you end up having to run it at a little bit drier environment than, say, for example, pepper plants. So that's one major difference. And the other major difference is the density of its bud. Its bud is extremely dense, and it's a sponge. You know, so if you don't have proper mixing inside that environment, that bud will radiate heat out at nighttime, infrared radiation, cool off, right? This is the same thing that happens to all of us. We stand outside, and that's why dew occurs, right, in grass. The grass radiated heat at nighttime, got cooler than, it's a plant, it's transpiring, it got cooler than the outside environment, water condensed on it, it's got dew or frost. Same thing's true about a bud in a greenhouse environment if you're not maintaining the greenhouse environment properly. It's true about the same thing in a warehouse environment too, by the way. But so it's a dense bud, it's losing heat, it's transpiring. If you don't have proper mixing in that environment, it's easy for it to condense moisture inside that bud and get bud rot.
Yeah, and I hear a lot of comparisons with cannabis and tomatoes. And I've grown both before commercially. And a huge difference I see is really going into, a lot of times when you go into a cannabis facility, they're packing in as many plants as they possibly can. And some of that kind of goes down into cultural control too when it comes to integrated pest management and stuff, would be removing some of those leaves, making sure you have proper airflow going through. But when you're typically commercially growing a tomato plant, you're using a high wire system and you have these vines that are going up and you're pruning to one head or one apical meristem and you're really just trying to, your plant's going up, there's not a ton of foliage. Once that high wire system gets closer to the ground, all those leaves are taken off. That plant keeps growing and you keep wrapping it. So there's not tons of foliage where you can have microclimates that can really start to cause mildews and molds compared to a cannabis plant where you see a lot of them packed in, leaves crossing each other, and you have microclimates in here that are going to be a little bit tougher for you to get air circulation in. So I think some of that kind of comes into play when people are comparing tomatoes to cannabis. I mean, there's a lot when we go into nutrients and all that stuff too, but that's something to kind of keep in mind. There's a lot more airflow in a tomato house than there is, or available airflow, I should say, and less foliage compared to a cannabis facility.
Well, the first thing I would do is agree that the balance of the fine leaves and the dense bud make it pretty unique. But from strictly a production standpoint, the big difference of growing cannabis versus another vegetable is you can't spray Eagle 20 on cannabis. You're not super concentrating your tomato and freebasing it off a piece of titanium. You're not smoking your blueberry. You're washing your blueberry. So there's a lot of things that you would do in other traditional agriculture methods to different types of IPM, different types you do if the plant was sick or had bugs or this, that, whatever, that you simply can't do with cannabis. And I think that alone makes it unique in and of itself. We could go on and on and on about the actual science and really work these guys' degrees here, but from a grower standpoint, you can't spray it. There's the 100 things that you would do in your home vegetable garden you can't do with cannabis, or you're going to fail your test and it's not going to make it to market. End of story.
And to Mike's point, we can't afford, not only can we not use a lot of pesticides that other crops can use, but we can't afford to have any kind of disease on cannabis. It is a medicine. It's different than a tomato. If a tomato has some powdery mildew, we're not selling the foliage. We're selling the fruit, and the fruit can be washed off and cleaned and things of that nature. So it's not as critical on a lot of other crops. One thing I would point to that I think has been a phenomenal sort of evolution of the industry, and these fans have actually been around for a long time, but they've just recently got a new manufacturer making them, and have really caught a lot of momentum. But the vertical airflow fans, I think, are really important as far as disease pressure, because not only are they allowing us, a lot of greenhouse crops are smaller crops, like Nick mentioned. They're not packed as densely together. So, horizontal airflow fans that are doing these serpentine patterns or these circular patterns, there are a lot of microclimates with those type of systems, whereas with the vertical airflow fans, we're getting more localized air movement on the plant, so we're having less of that microclimate. And not only are we getting more localized air movement, but we're getting it where we need it the most, which is right at the top of that crop. Right at the top of the crop where those biggest flowers are, that's where the most transpiration needs to be going on. If for whatever reason the environmental controls get out of whack, or somebody is overwatering the plant, all of a sudden there's just not enough transpiration taking place in those really thick, dense flowers at the top of the crop, and that's typically where we're seeing something like botrytis, that bud mold happening. So being able to have that vertical airflow and that air movement right on top of the crop is really important, and it's causing more less stratification of the air, so that we are getting more consistent humidities from the top of the houses or the top of the grow room to the bottom of the grow room as well.
One thing that I would just add to that is that one of the other things that's really unique about cannabis is that everybody kind of has their own way to do it. Here, he's just talking about growing, really big plants with bigger buds. There's guys that do see agreeing with a ton of small plants with smaller buds. Whether you're growing for flower, whether you're growing for concentrate. Is this, going for top shelf? Is this going to edibles? So, in most cases with other types of, agriculture, it's, well, you grow your blueberries this way, you grow your pineapples this way, whatever. But with cannabis, it's like, well, his way is this, his way is that, his way is that. I think this, she thinks that. I mean, it's what, there's a lot of different ways to skin the cat. So that alone is a very unique challenge. There's not there are a lot of books out there, so I guess that's a bad example, but there's not a lot of great books that are out there that you can necessarily just pick up and get into it the way you could, go buy a soybean farm and pick up the farmer's manual on soybean farming that's the best practices for the last 100 years. So it just simply doesn't exist yet.
I have a question about vapor pressure differential. Is it a different number for warehouses versus greenhouses? There was a Desert Air guy yesterday said like 1.4 kilopascals, and I think you said 0.8 to 1, 0.85 to 1. So is it a different number indoors, and why is that?
I believe so. I think the primary driver for that is what the temperature that comes out of the ductwork for a warehouse grow. So remember that temperature is coming out in the 50s, somewhere in that range, most often, and it's the air that's coming into that, because these are research systems, right? We're trying to create isolation in a warehouse environment. So these are research systems. The air going into it might be 75 degrees, 50% relative humidity. But by the time you drop it down to 50-something degrees, now you end up being real close to the dew point. And so what I think they would do is that if you were running a system based off of VPD, you'd actually raise that vapor pressure deficit to a close number to 1.2 maybe. And so the difference in the greenhouse environment is we really just don't have that cold air blowing on the crop.
I think that was great.
Yeah, I had nothing to add to that. That was pretty good.
That's a good question.
All the science questions can go down that side.
Thanks, gentlemen, for all the input. Jim Kelly. Mike, you made a comment about Salinas, and I spend an awful lot of time in Salinas. You basically say you don't like evap. Is it because you don't like negative pressure evap?
I don't like the idea of seeing dumpsters full of plants behind the greenhouse.
So where do you go for cooling? Do you go to chilling? Do you go to positive pressure? It's a very humid place.
Yeah, I like to see like the dry air style dehumidification systems in a situation like that. Again, some of those structures are so large that you're talking about multiple of those units, and at that point it might not necessarily be cost effective, but if we can, in my opinion, if you can avoid adding that much into it, because you are going to have a different climate in front of the pad versus at the end of the pad, and length of the greenhouse and how fast that air is moving, all that stuff comes into play. And again, all you have to do is walk around some of those greenhouses in Salinas, and the amount of waste product is simply unacceptable in the cannabis market, whether it's a plant count or not. So, I think systems like the dry air or other comparable systems, I think there's a couple other manufacturers that are doing that Israeli style, seem to have really done a good job of spreading that air around evenly so that you don't necessarily have, the tray or the row in front of the pad being that much different than, the
Well, that's a big
in the
difference
middle.
between a positive pressure room
Yeah.
and a negative pressure room too.
So, again, Salinas is tough because in that specific area, a lot of times these guys are kind of forced into what's there because they're trying to get these plants in the ground to get the available licensure, because if you're not growing, you're not getting the license. So, we see a lot of cases down there where, it would be great to change X, Y, and Z, but you're talking about a 12-month timeline when they have to have plants in the ground by the 1st of January.
Yep.
So, sometimes your hands are somewhat bound, and you got to kind of be able to overcome and adapt. And maybe if you are in the place with the wet wall, maybe that that kind of helps you decide what growing methodology you're gonna grow with. If you're in the wet wall, I'm not sure I'd want 5-gallon, deep water culture buckets, right?
Yep.
So it's just, again, having that practical knowledge of knowing what types of different growing methods are gonna make sense in that framework that you have that you may or may not be able to decide.
Okay, thank you, gentlemen.
But also in the higher humidity areas like you were mentioning, I do think chiller systems is a good thing to look into.
Yeah, especially if you happen to have cogen.
Hey, thanks guys for all that you do. Mike, you sound a lot like Eric and everything that he preaches, so I appreciate you guys aligning similarly in your company. Can you talk about the pill and how Eric explains the outdoor grower versus the indoor grower? I'm an indoor grower myself in a 12,000 square foot medical facility. I'm on a strict plant count, like you said, mold issues, not acceptable. So we just simply don't have it. The botrytis thing's an eye-opener for me. I have been having some top rot, and now I think I know how to fix it. Thank you, guys. The pill, and how do we do greenhouses in Colorado? I was just hearing about Oregon struggles, California struggles, Florida struggles. I'm gonna grow here in this state in a greenhouse, and I wanted to build a gable greenhouse with all the bells and whistles. I have no indoor or greenhouse experience, so I've decided to switch gears and go cold frame to start and work my way up into the greenhouse grower I want to become.
Very smart.
I suggest this is something you all take into consideration. Pull my own tarps manually versus buying automation initially. And then when I get more comfortable with it, of course I want to use a Wadwords controller. Of course I want to build a Nexus Gable greenhouse. So how do I get there?
Well, I think exactly what you're doing is starting with the basic cold frame. We get people that come to us all the time, and I'm sure Nexus can tell you the same thing, and they say, hey, look, we're brand new to the game, and we want to start with 100 acres. And, it's like, okay, cool, what's your team look like? And they're like, well, I'm the money guy, and my nephew has grown weed for 2 years in college. He's our master grower. And it's like, whoa. So starting out with the cold frame, understanding the basics of, what the greenhouse can do for you is exactly what you can do. And basically, if you can get through a successful year in the cold frame, you're going to have a pretty good idea of your climate. Because even in Colorado, there's a lot of microclimates. What works in Evergreen is a little bit different than what might work down in Pueblo versus Aurora. So, again, you still have those same types of challenges. So starting in the cold frame, understanding how basic greenhouse production works, and basically understanding that you're letting Mother Nature do the work versus your HVAC system. And that's a huge difference. And that's what I was, trying to get at earlier when I mentioned how the irony of some of these places with all natural in their name, and you go into their grow room and it's like a state-of-the-art ISO 9000 NASA facility. And there's nothing really natural about that. There's no natural sunlight. All the nutrients come from a bottle. All the air's been scrubbed. Where is one single natural part of that thing, right? So, again, that's just me being a little bit more biased towards the greenhouse, but I think what you're doing is exactly what you should be doing, and really everybody can take a page out of your book that wants to get into the greenhouse game, because whether or not you've been growing production for other crops in a greenhouse, switching over to cannabis is going to have its own little subtle differences. So learning kind of how to tame the plant with what Mother Nature gives you in your specific area in a cold frame, which is going to be much easier to permit, much lower cost, much quicker to get off the ground, will let you know if you are ready to make the jump towards a bigger commercial structure, because you're talking $2,000 for a cold frame versus $6,000 to potentially however many figures for a commercial greenhouse.
Sorry, supporting the plant versus forcing the plant, that's what you're talking about, right?
Yeah, I mean, like I said, you got to kind of let the plants do, what they do best. These things have been surviving a lot longer than we have. These things have been here a lot longer than we have. So to think that, we're going to come in and all of a sudden decide what's best, the greenhouse will kind of really make you take a back seat to what is going on. And if you keep your plants healthy, you can avoid all these other types of issues. Healthy plants don't get sick. Healthy plants don't get bugs. So, things like putting in proper IPM techniques, keeping those plants happy, goes a long way.
I definitely recommend starting with one facility, like you were mentioning. There's a lot of times you see people building a bunch of facilities and they don't have their standard operating procedures in place. Or maybe they think they do. And I know one of these guys talked about starting with one facility and then they build another facility and it looks a lot different than the first facility because you've learned. You've figured out things like, oh, maybe we should have done this differently. So starting with one facility, especially going from an indoor facility to an outdoor facility, there's gonna be a lot of changes from how your cooling works, from your irrigation schedules, to your lighting, because now you're using supplemental lighting instead of one source lighting. So knowing what your outside PAR values are, knowing your DLI. A lot of these things come into play from transitioning from an indoor grow into a greenhouse grow.
And I will say Colorado is one of the best states for greenhouses, hands down.
Hot and dry, right?
Hot and dry. Can't do much, and sunny. Can't do much better than that.
One of the things that Mike mentioned earlier was sort of pumping the brakes and slowing down a little bit as far as designing and building these structures. I find that it's something we run into a lot where we get a new client and immediately they're like, okay, can we be growing in this thing next month type of thing or in 60 days? Could you guys give an example of without driving you guys crazy, what's a realistic time frame for somebody to engage you guys with a contract to actually have a fully installed functional facility?
That, to me, that kind of depends on your jurisdiction, like where this thing is actually going to be built, because that could add up to 12 months. But assuming that's all equal, you could be anywhere from 2 months to 12 months, depending on the size. It really depends on what you're doing and how you're trying to do it. Trying to put up 2 acres versus putting up a 40 by 120 is a lot different.
And I'll kind of outline some of the steps maybe so you can see where that range comes from, because I agree with Mike there. Our average project time, I would say, is probably closer to 5 or 6 months, but that's from the time that we have all the green lights, right? So you get your grower's permit or whatever you're gonna have, depending on the location you're in, what state you're in, and you start talking with us and you say, okay, first thing I want to do is I want to talk with an architect, because he's going to have, if you're going to get a building permit for this building, he's going to be the most critical person to work with, and you want to get somebody that knows the product, knows this industry, knows the product, knows the building department, and understands the flow of everything that's going on. We'll sit down, we'll get a design to the customer. It takes a couple weeks between us and the architect going back and forth, looking at the site layout, you name it. And then from there, we'll work on a proposal. We'll go out and integrate all the systems together, get a proposal, engineer that stuff, get some drawings going, so you could go to the building department. All that might take up to a month, typically speaking. But you're ready to go to the building department at that point. Assuming the building department's all good to go, manufacturing could take 6 to 8 weeks, depending on the scale of your project, and then the build out, depending on the time of the year you're building and where you're building, that usually goes I don't know, anywhere from 8 weeks to 3 months. So on average, you're looking about, from the time you're really ready to move, you're looking about 6 months. If you're going to the building department, you got to go through all those hoops and ladders.
The only thing that I would add is just stressing how much of a headache the building department and the permitting process can be. I mean, even just waiting on engineered plans, can take 2 to 3 weeks, depending on how backed up the engineering firm is, things like that. So a lot of times it's hurry up and wait, and I'm sure you run into that all the time. And it's just trying to keep, the big thing with the greenhouse design is really just keeping yourself in reality. It's really easy in the cannabis industry to get these really inflated ideas of how things are going to work and live in this dreamland, and there's no shortage of people that'll keep pumping you and getting that balloon more and more inflated, but it doesn't always work like that. Okay, building a greenhouse is pretty similar to building a house. You're not going to decide, okay, I want to build this brick house and just throw it up. It needs a permit, it needs engineering, it needs 30 contractors, 30 vendors to kind of come together and deliver at the same time, and trucks and this and that. So it's definitely not an overnight process. Unfortunately, that's a great timeline, but if the building department is 9 months out, you're 9 months out, and that's not Nexus's fault, and that's not Forever Flowering's fault or anybody's fault, so to speak. It's just, how it goes, unfortunately. Unless you're talking about things like a cold frame. Like one of the things with the cold frame, we just did a big job out in Carbondale. These guys are waiting on their to get approved to put up an actual steel frame structure, but we're starting them out with cold frames because they're not considered non-ag structures by the county because they're below a certain height, and they're considered a temporary structure. So he could throw up all the ribs. He's got 5 acres of cold frame up right now, and we just took the plastics off for the winter. So guess what? As soon as the spring comes around, throws those plastics back on, ready to start light depping right there. So that's a way that you could get around up to half a year or longer turnaround. But again, it all kind of depends on where you're at and how your liaison is going with the building department. That's such a huge one, and we're all under that one spell.
I think we're about out of time, so I'd like to thank everybody for coming today, and I believe most of the panel will be around for a couple minutes if anybody has any specific questions for any of us.